in this video we're going to look at fuels, and we're specifically going to look at fractional distillation and hydrogen production. So our learning intentions are to discuss fractional distillation, including its products and uses, and to explore the manufacturing of hydrogen by electrolysis and steam reforming. So up until now we've really kind of been looking at hydrocarbons and hydrocarbon families and their properties and how they can be produced and how to name them. But what we're going to look at now is we're going to look at oil refining and its products. And when we look at oil refining, we need to look at crude oil. And crude oil is a fossil fuel, and the definition for that is in the alkanes video. But crude oil mainly consists of hydrocarbons. And crude oil is useful as it can be sorted into batches called fractions, and these batches can be separated by a process called fractional distillation. So in fractional distillation, crude oil is pumped from under the ground or under the sea into a furnace where it's heated to very, very high temperatures, and it then enters something called a fractional distillation column. And in this column, substances are separated as group of compounds based on their boiling points, and these groups are called fractions. So these are the steps to fractional distillation. So as I said, the crude oil, it's pumped from under the ground or under the sea, and it's analysed and brought to a refinery where it's heated in a furnace to 600 degrees, and it is vaporised. The vapour enters the bottom of a distillation column. It's called a fractional distillation column, and it contains a series of trays. So vapours containing the lightest molecular weight, or having the lightest molecular weight hydrocarbons, rise to the top, and the heavier hydrocarbons stay lower in the tower. The various fractions are collected as each hydrocarbon reaches its distinct boiling point, and the temperature decreases as you go up the column. So the smaller hydrocarbons, basically they stay vaporized and they rise up through the trays as the fractional distillation column gets colder, the temperature decreases as the height goes up. So the different fractions, substances distill off at different fractions or trays, and based on where they distill off according to their boiling point, we can know what group of hydrocarbons that they represent. So here's a very simple diagram to explain it to you. The crude oil is brought into a furnace where it's heated up and vaporized, and it enters the fractional distillation column. And the light vapours rise to the top where they condense and distill off at different temperatures. So let's have a look at the different fractions that there is. So fraction 1 is the refinery oil, and it mainly consists of liquefied petroleum gas, which is LPG, and it's used for cooking. And this has carbon chains of lengths 1 to 4, so it's methane, ethane, propane and butane. And this is the fraction that is at the very top of the distillation column, and it has a temperature of approximately 25 degrees. The second one is the light gasoline, and in the light gasoline, this is mainly petrol for cars. It has carbon chains of length 5 to 8, so that's pentane, hexane, heptane and octane, and it has a boiling point of between 40 and 75 degrees. The third tray, or the third fraction, is called naphtha, and it contains hydrocarbons of lengths between C7 and C10. It has a boiling point of approximately 75 to 150 degrees, and in the naphtha, this is where we get a source of a large number of useful chemicals for the petrochemical industry and feedstock for petrol. So example, we get a large number of chemicals that are useful for detergents and medicine. So the fourth fraction is called the kerosene fraction, and it is from C10 to C14. It has a boiling point of between 150 and 240 degrees. It can often be referred to as the paraffin oil fraction, and it mainly distills off fuels for aircrafts, or kerosene for central heating. The fifth fraction that we look at is the gas oil fraction, and this can often be referred to as the diesel oil, and it has carbon chains of lengths 14 to 19 with a boiling point of somewhere between 220 and 350 degrees. So because these carbon chains are now getting longer, they are heavier, so they have to have higher boiling points. And in the gas oil fraction, usually that's where we get diesel for buses and trucks and trains and cars. The sixth fraction that we look at then is the residue fraction, which is everything underneath gas oil, and this is from carbon chains of length 30 onwards, and they have boiling points of 350 degrees upwards, and from here you can get lubricating oils, waxes, you can get polishes, fuels for the shipping industry, but you can also get in it bitumen, which is used for tarring roads. Now, for an exam, you may need to know like an example of some of the fractions. You may need to be able to describe how fractional distillation works, and you may need to be able to draw a diagram of a fractional distillation column. So it's worthwhile spending some time looking over these slides and creating some of your own short notes. So if we look at natural gas in particular, natural gas or refinery gas, it's mainly composed of the methane, ethane, propane and butane, and it's colourless and odourless, so it can be quite dangerous. So gas leak. So when you get a smell of gas, that's actually the mercaptans that are present in it. If we specifically look at petroleum, petroleum is a mixture of hydrocarbons. However, petroleum is used in cars all year round, and temperature can vary quite a lot. So the proportion of volatile hydrocarbons added to petroleum or to petrol is higher in the winter to help cold starting, but it is lower in the summer. So in the winter there's a lot more volatile hydrocarbons so that it's easier for engines to start and to prevent engine knocking. So starting point of production is the gasoline fraction, where most of the hydrocarbons fall into the C5 to C10 category as they're light and volatile. Now, so far we've mainly been focusing on fuels that are based on hydrocarbons, and the only other fuel on our course is hydrogen. And the two processes that we need to look with hydrogen and its manufacturing is steam reforming and electrolysis. So steam reforming actually involves reacting methane with steam in the presence of a suitable catalyst, and this catalyst is nickel, and it happens at a high temperature of 800 degrees. And when we do this, this produces hydrogen gas and carbon monoxide as per our balanced equation. Another way of producing hydrogen gas that you may be more familiar with from your junior cycle is electrolysis of water. So electrolysis is using electricity to break down a stable substance. And electrolysis can actually be quite expensive for water, as there is a high cost for the electricity needed. But electrolysis separates water into hydrogen and oxygen, and sometimes acidified sulfuric acid is added, and that's to improve conductivity, which you should have known from your junior cycle, and it occurs in a Hoffman voltameter. So that's it for this video. Have a read over the learning intentions to make sure you understand everything we've gone through.